Hey, welcome back. So I've already made a bunch of videos about all the modifications I've done to my lathe here, but we've never really looked at the milling machine in detail, so I figured it's time to show you all of the stuff I've changed and improved on this machine as well. Not all of the things I'm going to show you today are technically mods, some are just little tricks and solutions I found to make work a bit easier, but I think almost all of it can also apply to other shops and machines, so feel free to copy any of these ideas, and with that, let's get started. First of all, just to give you a quick overview, I've had this mill for about 6 years and it cost me about 3,200 euros without the DRO when I got it. In case it's not obvious, this is a Chinese import mill. This particular model is the SX4 from a manufacturer called Zeek, and I bought this from a reseller here in Germany. As usual with this type of machine, you can find various clones that are sold by other companies. For example, Axminster and Grizzly both sell a version of this machine. Or at least they used to, because I actually couldn't find it on their websites anymore. The table size on this is 820 by 240 millimeters. It's driven by a 1.5 kilowatt or 2 horsepower motor. It has a pretty generous amount of travel on all axes for this type of mill, and it weighs about 350 kilos, so it's a pretty decent size and is about as large as these benchtop mills get. This isn't supposed to be a review of the mill though, I just want to say that overall I'm pretty happy with it. It has its quirks, but just like my lathe, I think this type of machine is well worth its money as long as you don't go in expecting a professional machine that costs 10 times as much. Throughout my channel you can see all the stuff I've built on these two machines over the years, and it would be an understatement to say that they've served me well. So let's start with something simple that I think almost every mill needs, and that is table covers. Most machinists will probably do the majority of their work in the main vise, so having the T-slots constantly exposed isn't necessary, and cleaning chips out of those gets really tedious, so here's a few different ways to prevent that. The first covers I made are these ones. These are very simple and effective and super easy to make. All this is just a 2mm aluminum sheet cut to the right size, and on the bottom I just screwed a single strip of plywood that I cut to the width of the table slots, and that's all that's necessary to keep these in place. Unless you're mounting stuff into your slots constantly, I really suggest making a set of these, because apart from saving you a lot of cleanup work, they also protect both your table surface and also your tools, which is why I chose aluminum for these. If you drop a pointy steel tool like this on the covers, neither the table nor the tool will take any damage this way, and keeping the table in good condition is not only going to make sure it stays accurate, but it's also one of the first things people look at when buying a used machine, so having a banged up table can really affect your resale value. That being said, these covers do have two disadvantages. One is that you can't use flood coolant because it will just run off the table, and the other one is the fact that you can't use the table surface as a reference for measuring or lining things with these installed, and that's why I also created a different solution at some point. This type takes a little bit more work to make. These inserts were made from a strip of aluminum flat bar that I milled to the width of the T-slots, and then I cut a whole bunch of these little standoffs on the lathe and tapped threads into them. And when assembled, these make the strips sit slightly below the table surface. For the pockets on the side, I got a bit lazy and just printed some covers, and I've also seen people 3D print the slot inserts as well, so that's also an option. The main advantage of this solution is that the slots are protected against chips, but you're still able to fully utilize the table as a reference surface. So let's say I want to use standoffs to support a long part and make sure it's parallel to the table. This way I can still do that without taking the thickness or potential inaccuracy of the sheet metal into account. Another thing that's nice about this solution is that it allows you to selectively expose slots. So let's say I want to clamp something to the table here. In this case I'd only end up with chips in one slot instead of all of them. And in case you're using flood coolant, this solution also allows it to drain into the gaps. The disadvantage is of course that the table is now exposed to potential damage from dropping tools or workpieces again. But it's actually possible to even use different solutions on each side of the vise, so you can also sort of have the best of both worlds. Personally, I ended up using the sheet metal covers 90% of the time because they're just the most straightforward, but now you know two options. So let's move on to the second mod, which is this chip shield. This consists of a steel frame fitted with polycarbonate sheets that attaches to the mill table and significantly reduces the mess when machining by keeping chips from flying all over the shop. For me, this is another must-have modification because I like to keep a clean shop, and this really does reduce the mess by a huge degree. I basically never have to clean those hard-to-reach areas behind the mill this way, and there's barely any cleanup on the mill itself except for the table. As I mentioned, the panels here are made from polycarbonate, which is an extremely tough and flexible material and basically impossible to shatter even when it's hit by really hard objects. I designed this so that it's a good compromise between not getting in the way of most milling operations, but still catching 90% of the chips that fly towards the back in a typical setup. It provides enough clearance so that I can still reach all the way down to the mill table with an average tool, but at the same time it's tall enough to work even with relatively tall workpieces. Of course there are situations where it either won't catch all the chips or more likely will just get in the way, and that's why the main goal was to make this as easy to remove as possible. The entire thing can just simply be pulled off the table. There's no screws attaching anything, there's no magnets or any kind of locking mechanism. The only things keeping this in place are a tight fit and gravity. So it literally only takes about 5 seconds to remove it or put it back on. An important thing to note is that the back wall is set back slightly here, and this is necessary to avoid clearance issues with the spindle when you're working close to the fixed jaw of the vise. Unfortunately, this is another one of those things that I never filmed when I made it, but let me just pull this off to show you how it's put together in more detail. This mainly consists of a long piece of angle iron in the Z direction, which has these cutouts on the side there to provide clearance for the drainage plugs in the table. Then we have a smaller piece of angle iron that extends upwards and a piece of flat bar on each side with 2 tabs to align it to the edge of the table. I also put a few small tabs to attach the polycarbonate sheets, which are all tapped for M4 screws. And yeah, I admit I was too lazy to shorten these screws because they're hidden in the back. If you're wondering about that large piece of steel on front here, this serves 2 purposes. First of all, it aligns the frame against the side of the table and that black plate. And the reason it's so thick is just because the frame is quite back heavy, so this provides a counterweight in front to balance it and keep everything snug. And speaking of snug, the reason this thing fits so well is actually quite simple and also makes this build pretty easy. After cutting my stock, I just put some welding magnets to align the pieces directly on the table, and then I tack welded everything in place, took it off and finished the welds. And that way it's very easy to make and is guaranteed to fit the table perfectly. As for the polycarbonate, you can actually cut that stuff with a table saw or a handheld circular saw, so it's quite easy to work with, and building this whole chip enclosure only took about half a day, so it's another mod that I can really recommend. The third mod for today is easily one of my favorite things I ever built, and that's the custom power feed for the X-axis. You can actually buy a power feed for this mill from the original manufacturer, but besides the fact that it has a lot of bad reviews online, it also costs something like 400 bucks, and I just wasn't willing to spend that much, so I built this thing. This mainly consists of a wiper motor, which are great for this kind of thing because they're really cheap thanks to mass production. They're compact and they deliver high torque at low RPM thanks to a built-in worm gear, so they're kind of perfect for this purpose. When I originally built this, I actually used this motor, which is a 24 volt version found in most normal cars. But I eventually switched to this bigger 48 volt motor for trucks, which has slightly more power, but in retrospect the difference wasn't that big and the other one worked about as well, so there's no need to get hung up on that. The motor is controlled by this little box that contains a cheap PWM controller, which is basically just an adjustable DC voltage converter. It's not the greatest way to control motor speed because you do lose torque with this method, but it works fine for this purpose and you can get these for 10 to 20 bucks. And if you go to a junkyard, you can probably find a wiper motor for less than 10, so it's possible to build this entire power feed for under 50 bucks, which is hard to beat. The number displayed here is the voltage in percent, so unfortunately I can't see the actual speed it's going at, but I never found that to be an issue. The little switch starts the motor in each direction, and then the turbo button down there just goes to 100% when you press it. The range of speed you get with this is pretty decent. As you can see here, it can crawl very slowly at the lowest setting, and the rapid feed can save you a lot of time, especially for things like indicating a vise. I did actually make a video many years ago about building this, which is why I'm not showing that in detail here. I'm gonna link that in the description along with some other relevant videos if you want to see this build in more detail. But right now let's just remove these covers and I'll quickly show you how the mechanism works. The main thing that makes this so easy to build is that instead of making some complicated clutch mechanism, the whole motor simply slides on and off the spindle to engage or disengage the feed. This is the original side plate that's on the mill table, and I just slightly modified this by attaching this little housing which contains a plastic bushing and an adapter that connects to the X-axis spindle and converts it to a hex drive. So when I move the hand wheel on the other side, you can see it spinning here, and then on the motor side we have this mounting plate, and the motor itself also has an adapter which is made from an old hex socket, and that allows it to engage with the spindle. To hold this all together, we have two sleeves that are screwed into the plate on the table, and then on the motor plate there's two pins that fit into those sleeves, and they each have a slot that prevents the whole thing from sliding all the way off thanks to the set screws in the sleeves. Another thing I added eventually, mostly since so many people commented on it, is end stops. There's a stop switch on each side of the saddle here now that gets pressed in by these tabs that are just attached to the front T-slot on the table. The stop switches then completely cut power to the controller, which I think is the safest option, although it does require me to move the table back manually once the switch is engaged. I've been using this Powerfeed for about 5 years now, and I literally never had a single problem with it. I think it perfectly hits that balance of being about as simple as it gets and kind of frugal, but also very robust and reliable. Once again, I think you can adapt this principle for most mills, so if you've always wanted a Powerfeed and you got $50 and some time to spare, this should be a very satisfying project that's also beginner friendly. While we're down here, maybe you notice this thing, and that's a custom Y cover I built for the front portion of the Y axis. This mill does come with bellows for the Y and Z axis, and they're actually really good and work perfectly, but unfortunately there's no protection at all in front of the table. So when you move it all the way back, the Ys and even the spindle are exposed. So I built this relatively simple solution, which is just a piece of very durable fabric that's sandwiched between some aluminum strips. This works quite well and barely affects the travel of the table, but the downside is that it makes reaching the locking handles for the X-axis a bit more difficult, which is probably why the manufacturer didn't include any covers here. In this case, you can simply remove the cover very easily to get access down there, because the front part simply hooks into these two pins that I machined and is once again just held by gravity. I really try to avoid using magnets for this kind of thing because they end up collecting chips, and this works perfectly fine without them. That being said, if I'm being completely honest, I'm still not 100% happy with this solution. Reaching the locking handles down there is easy enough now, but somehow it still feels a little awkward. So I ended up just installing this when I machine stuff like cast iron, where protecting the waist is more important. But maybe I'll come up with something more elaborate in the future. Before we get to the next mod, I just want to give a quick shout out to today's sponsor, revopoint. Since I assume a lot of you use CAD software, this one might be quite interesting for you, because revopoint recently sent me their latest 3D scanner, which is called the Trackit, and it delivers professional 3D scanning performance at a very competitive price point. In this example, I'm scanning this e-bike motor to figure out clearances for one of my upcoming bike builds. With the Trackit, this is very straightforward because it utilizes an advanced optical tracking system, usually only found in scanners that can cost 10 times as much. The huge benefit of this system is that it completely removes the need to use any markers during scanning. Pretty much all other scanners in the Trackit's price segment require you to place countless of these marker stickers on the object you want to scan, which is very time consuming, and even then the tracking often doesn't work well. But thanks to the advanced tracking system, you can forget about all that with the Trackit and just start your scans without any special preparation. The Trackit is also very good at handling black or shiny objects like this one, and you can scan tiny parts all the way up to entire cars. After the scan, the included software takes you through all the steps of refining the scanning data into a clean model, a lot of which can be automated, and as you can see, I ended up with an extremely detailed and very clean model here on the first try, which I can now insert into my design to use as a reference. Other notable features on the Trackit are that it comes in some really high quality transport cases and also has an automatic calibration feature. To give you another example, I also scanned part of my bandsaw here because I'm planning to build a new base for it, and this is another case where it would have taken forever to model all this in CAD by hand. So if you ever run into situations where you need to put complex real-life objects into your CAD model, you should definitely consider checking out the Trackit. If you want to know more about the scanner, I also recently made an entire video about it, where you can see the setup of the device, the scanning process, and the included software in much more detail. along with some more scanning examples, which should give you a good idea of what kind of performance you can expect from this. You can find that in the description along with a link where you can get the Trackit on Kickstarter, and if you're quick you can currently still get a nice discount. And with that, let's get back to the video and take a look at the next mod, which is another one I would consider a must-have, at least for this particular mill, and that's the spindle stop. The reason is that in order to do a tool change with this mill in its original state, you actually need 3 separate tools, which felt way too clunky to me, but let me explain. First you insert an Allen key into the drawbar up here, and then you need to stick this little pin into this hole to block the spindle from turning. Then you can release the drawbar, but as is usually the case with tapered tooling, you also need to give the drawbar a little whack with the hammer to actually get the tool to release. Then you unscrew the drawbar all the way and the tool comes out, you put the new tool in, tighten the drawbar once again, and you need a little pin to block the spindle again. I thought this was way too inconvenient, so I came up with a proper spindle locking mechanism. This is actually just 2 steel rings that I machined to fit on the bottom of the spindle and the quill housing. The top ring has this little spring-loaded pin attached that fits into the holes on the bottom ring, so all you gotta do to hold the spindle is just turn it slightly and press the pin into one of the holes, and that completely gets rid of any need to use an additional tool for this. Another bonus is that this can also be used to block the spindle to tighten and loosen the nut on collet chucks. Apart from that, it's also possible to actually screw the 2 rings together in case you want to lock the spindle completely in place for doing some weirdo stuff like using the quill as a slotting head. So that gets rid of the pin tool, but now we still have the hammer and Allen key, and in this case I decided to simply integrate them into one tool. This thing has a hex key at the bottom, which is just the end of a cheap Allen key that I welded to a piece of rod. Then we have this handle in the middle, which also serves to add balance and act kind of like a flywheel. And on top there's a screw with a fairly strong spring and this steel cylinder. You just pull this up with your thumb and release it, and it then works just like a slide hammer. I also attached this ring to the drawbar housing here so that the tool can live exactly where it's needed, and with those 2 solutions combined the tool change is much faster now. I just insert this tool up top, then I can lock the spindle and loosen the drawbar, give it a little whack to release the tool, and then just give the whole wrench a spin to quickly unscrew it. And just to give you an idea how long this whole process takes with some practice, let's do some quick tool changes in real time. I timed these at about 12 seconds, and while it's of course not as fast or convenient as a power drawbar, it's definitely a huge improvement over the stock solution, and so far I haven't felt the need to go any further. So let's move on to the lighting now. This mill actually comes with a work light, but it's not that useful. It creates this really bright spotlight which is kind of impractical and doesn't offer a lot of adjustability, so I eventually installed these LED lights directly underneath the head and never looked back. These create a really nice uniform light directly where you need it, and once again this was a very cheap and straightforward mod. All this is a bunch of cheap LED strips that I put into some aluminum LED channels. I really like these channels, so I've used them in a lot of different projects and places around the shop. You can find them on eBay or similar sites. They're fairly cheap and they come with either a clear or frosted cover. And then you just stick in whatever LED strip you want, solder on some wires, and you end up with a light that's very cheap and easy to make, highly customizable, and looks way less messy or botched than just sticking a naked LED strip to something. I then wired those into the main control box and installed a switch there to turn them on or off. And once again, this is the kind of thing you can add to your mill in less than a day of work, but it makes a huge difference. The next one is not so much a mod, but more of an addition, but I felt it's still worth talking about for a second. You might have wondered what this contraption is that's attached to the mill base here, and that's a mist coolant system that I got because I'm just not set up or willing to deal with the mess that comes with running flood coolant. This particular system is from a German company called Dynacut, and it's similar to the Fogbuster you can get in the US. I'm not sponsored by either of those companies, I just think it's a good product. You can also find much cheaper mist coolant setups on sites like AliExpress, and I actually tried those before I got this, but the problem with those is that they use a different principle called the Venturi effect to disperse the coolant, which causes it to not just spray onto the workpiece, but as a byproduct it also creates a gas mixture of air and coolant at the nozzle that floats around the room, which means you're basically breathing in coolant when using those. Needless to say, that's very unhealthy, but apart from that they're also just a pain to use in general, so I think it's really worth investing into a proper fogless cooling system like this one. In my case, I attached the nozzle unit to a mag base, which allows me to use this in various positions on both the mill and the lathe, which is one of the many reasons I keep these machines next to each other. Compared to the cheap versions where I always got either too much flow or none at all, this one just works incredibly well. You can precisely adjust the amount of coolant that comes out of this from just the slightest mist all the way to something that's almost like flood coolant. And I also really like that it has an electric valve, so it's very easy to turn on and off. Next, I just want to quickly show you the base I made for this mill. Even though this is technically still a benchtop mill, it's one of the largest and heaviest ones, so I wouldn't recommend just placing this on a normal workbench unless it's a very sturdy one. I built this base specifically for this type of machine. It's made from 50 by 3mm square tubing and it has two large drawers with full extension slides. In the top one I mostly keep various accessories like collets, parallels and additional tooling. And then the bottom one is admittedly kind of a junk drawer, so let's not look too closely at that. One thing that's nice about building a steel base and not painting it is that you can just keep adding features to it as the need arises. So I attached this post where I keep my most used cutting tools as well as a hammer, collet wrench and a little paintbrush to clear chips. But probably the best feature I added to this is this desk lamp on top. This is another cheap solution I use all around the shop. It's an IKEA desk lamp that only costs 10 bucks and for that money they're surprisingly good quality and super versatile. Since this is mounted pretty far up, I can adjust it to get extra light almost anywhere around the mill when I need it, which not only helps when using the machine, but I found it's also super handy for maintenance tasks. For 10 bucks you really can't go wrong, so I think it's worth just getting one or two of these and putting them around the shop, and you might be surprised how handy they are. Let's move on to another mod that's more specific to this mill, and that's the front panel. I completely switched this out with my own creation for a number of reasons. Mostly I didn't like the cheap plastic buttons the mill comes with and the fact that you have to keep the up or down buttons pressed the entire time you want to move the head up and down, because it moves quite slowly. I'm sure they did that for safety reasons and I understand why, but I'm willing to take the risk, so I went with a single up-down switch that keeps its position. I also put in some nice stainless steel LED buttons to start and stop the spindle, as well as a switch to turn on and off the spindle light. And then I also installed a custom RPM sensor. The reason is that this mill doesn't have a gearbox. The speed is controlled by a frequency drive, which does have its own RPM display, but that doesn't actually measure the RPM, but rather calculates it based on its programming. Since I wanted the option of changing the pulley ratio up top here to achieve higher speeds, the original display would then display the wrong RPM because the VFD obviously doesn't know the new transmission ratio unless you reprogram it. So the new display uses a Hall sensor to measure the actual speed directly at the spindle, and this way I always get a correct readout even when I change pulleys up here. Okay, so we're almost done now, but before we end this, I'm just quickly gonna run through a collection of smaller mods and additions. I made this little crank attachment for the quill feet because the mill didn't come with any for some reason. You might have also wondered what's up with this plate here, and behind that used to be another weird feature on this mill. There's an opening here that normally houses this miter box, which I guess you're supposed to use for measuring the angle when rotating the mill head. That's kind of a silly idea for a bunch of reasons that I don't have time to explain in detail, so I just removed that and started using it the way it was intended. Although I did remove the batteries and strapped a 9-volt block to it, since these stupid things constantly draw power when they're turned off. I then screwed the steel plate in the same spot instead, and this is actually extremely helpful because it provides a really good spot to attach mag bases. Most other areas on the mill head aren't suitable because the metal is either too thin or it has too much paint on it to safely attach a mag base with an expensive indicator. Apart from that, I also often use it to attach this adjustable chip shield I made, and if you want to know more about that, it's actually part of one of my lathe improvement videos that I'm gonna link in the description. Of course, I also exchanged all the handles on this machine for custom ones like I always do, because I have a pet peeve about cheap, noisy handles. So these ones are machined from aluminum and have ball bearings in them. I also made this very fancy looking handle for my main vise, and this is the kind of thing I don't normally make entire videos about, but I do often post stories on Instagram on making stuff like this. Last but not least, there's one thing that really made my life a lot easier ever since I added it, and that is having a dedicated shop vac at arm's reach right next to the mill and lathe. Before I had this, I would always have to walk over and extend a long hose from my main shop vac across the floor and then have to put everything back after, but this setup makes cleaning up quickly between cuts incredibly convenient. And the best thing is that since I use this shop vac exclusively to suck up chips, the filter never gets clogged with fine dust, so it doesn't even require you to put a bag in, because the chips allow enough air through. Thanks to that, it also has a lot more suction as well, and it really makes cleanup a breeze. So once again, highly recommend it, especially if you're a clean freak in the shop like I am. And I think that's all I got for now. There's probably something I forgot, so if you have any questions left or suggestions for further mods, feel free to write them in the comments, and as always, thanks for watching and see you next time.